Good afternoon, everyone. So yesterday we have discussed about introduction to your processor. Today we'll see what is an 8085 microprocessor. Okay. So 8085 is a 8-bit microprocessor which was introduced by Intel in 1977. Okay. So uh, it is it was a binary compatible with the more famous Intel 8086, but requires very less supporting hardware. Okay, so and prior to this, we have 8086 also that was introduced by Intel only in 1978. Okay, so next module we'll learn about this 8086. Okay, so and in 8085 it requires only less power supply, that is 5 volts is required. Okay, and when coming to your 80 after designing, after introducing this 8085, they have designed this Intel 8086 8080 also, and it requires a power supply of 12 volts. So let us see what are the main features of your 8085 microprocessor. Okay, it is an 8-bit microprocessor and it is manufactured by NMOS technology. So you have learned it in your previous semesters, what is NMOS technology and what is PMOS technology. Okay, so it consists of an 16-bit address bus. So it can have memory locations of 2 power 16. Okay, so if you take suppose if another microprocessor has 20-bit of address bus, then the memory locations will be in the form of 2 power 20. Okay, so for this 8085 microprocessor, you can see the memory locations will be depends on your address bus. Okay, so 2 power 16 is nothing but 65536 or 36 bytes. That is nothing but your 64 KB memory locations are there in your 8085. Okay, so next it has 8 data lines or data bus. Okay, so um, and it supports external interrupt request. It has a special function registers called program counter and stack pointer, and it has 6 8-bit general purpose registers in that will be arranged in pairs like B, C, D, E, H, L. So B consists of 8 bits, C consists of 8 bits, D consists of 8 bits, like that. Okay, that means every single register consists of 8 bits. Okay, so and it requires 3.2 megahertz of your clock frequency or your phase clock, and it is also called your clock speed. Okay, and the power supply required is for your 8085 is 5 volts. Okay, and it is enclosed with 40 pin dip in the sense dual in line package. That means 8085 consists of 40 pins. Okay, so in the next class we can see this pin diagram also. So today we'll see this 8085 architecture. So before that, I want to tell you one thing. So this address lines, whatever is there, that is that of your 8085 consists of 16 address buses and 8 data bus, right, or data lines, right? So this addresses and data lines are divided in such a way that so this lower bytes of addresses and data lines are multiplexed AD0 to AD7. Okay, and from A8 to A15 your address lines will be there. Okay, so that this address AD0 to AD7, this address and data lines are multiplexed. Okay, let us see 8085 architecture. Okay, so this is the 8085 architecture diagram. So it consists of an accumulator, a temporary register, a flag register, instruction register, and instruction decoder and machine cycle encoding. And you can see this, whatever the general purpose are there, you can see this B, C, D, E, H, L. So you can see this 8 bits, 8 bits, 8 bits, 8 bits, 8 bits. And the special two registers are there, that is your special function register, stack pointer, program counter. Okay. And you can see this one increment or decrement address latch is there, and you have an address buffer, data or address buffer. Okay, so this data lines are address lines are actually combined, so that will be combined with the help of your multiplexer. So if you want to send data or address lines together, this address latch will be used to send both. Okay, so whatever the latch is there, that will be helpful for your demultiplexer. Okay, so that is nothing but your address latch enable. Okay, so and you can see here control signals and status signals, direct memory access, reset, clock generation signals. So how this clock generation signals will be working means this x1 x2 are connected to your oscillator. So before this we'll see um, briefly about this diagram. Okay, so accumulator is nothing but it is also a storage purpose register, which is an 8-bit register which is used for storage purpose only. And you have one temporary register here. So arithmetic, when coming to your accumulator, whatever the arithmetical and logical operations we are going to perform, so that data will be stored in your accumulator. Okay, so next come to your temporary register. So this temporary register is also an 8-bit temporary register, which is used by your microprocessor. That means we cannot access, that is inaccessible to us programmers. Okay, so you after performing this ALU is nothing but it is used to perform your arithmetical and logical operations. Arithmetical operations in the sense addition, subtraction, multiplication, etc. And logical operations in the sense or, not, and etc. Okay, so after performing this arithmetical and logical operations, whatever the resultant is there, that will be decided by your flag register. So this flag register is also an 8-bit flag register. So in this flag registers you have parity flag, carry flag, auxiliary carry flag, zero flag, and sign flag. Okay, so how it is going to work, we'll see. So parity flag in the sense will have even parity flag and odd parity flag. Okay, so odd parity or even parity flag. When it is even, then whatever the resultant is even, then even parity is set. Okay, otherwise it is reset. Next, when coming to your carry flag, whenever you are going to perform addition operation for your 8-bit or 8-bit or 8-bit, so after the after performing 8th bit, if you get any carry, then if you get a carry, then your carry flag will be set. Okay, next we'll have zero flag. Zero flag in the sense after performing any addition or subtraction or multiplication, etc., if you get the resultant zero, then your zero flag will be set. Next is your sign flag. So after performing your subtraction or in multiplication or something else, if the resultant is positive or negative, if the result is positive, then your zero flag sign flag will be set. Okay, if the resultant is your negative, then it is reset. Okay, next coming to your auxiliary carry flag. Okay, so after the 4th bit, if you got carry, okay, so the operation whatever, suppose if you have taken 4 bit of arithmetic addition, after the 4th bit, if you got the carry, then auxiliary carry flag will be set. Okay, So this instruction register is there. Another